In question 3, you're given this cubic function f, which takes in an x and turns it into this expression involving the x cubed and the k's and so on. And what you're asked to do is to show that minus k is a root of this function f. So let me just quickly recap what a root is. Let's say that we have our graph system here, and we'll draw our function f, which is something along the lines of that. That's what an x cubed function looks like. Now, the roots of a function are also called the zeros of a function, which might be a more intuitive term for it, because that's where the output of the function has a value of 0. So if we're taking in some value of x, let's call this our x-axis, and this is fx, the output of the function. Then if we take some value of x here, like there, then fx is going to give us the height of that, which is here. So when is the height of this function 0? It's there, there, and there. So what happens is you take a number, put it into the function, and if that number is a root of the function, then you'll get 0 out of it. As I say then, we just need to test it out for x is equal to minus k. So we get minus k to the power of 3. The 1 minus k squared is already there. We're multiplying that by x, which in this case again is minus k, and we have a plus k at the end. So we're going to get the minus k cubed here. Remember, the minus to the power of 3 is going to be negative, and the k to the power of 3 is just going to be k cubed. The 1 times minus k is going to be minus k, and the minus k squared times minus k is going to be plus k cubed, and the plus k is still there, so all that stuff cancelled, the cubes cancel, and then the first powers cancel, so we get 0. And since it's 0, we can say so k is a root of f. Part B of this question says to find, in terms of k, the other two roots of f. Since f is a cubic function, it has 3 roots. We know that one of the roots is minus k, so there are 2 other roots that we don't know, and we have to find those in terms of k. So now we need to find the other 2 roots of this function f. How are we going to do that? We have a cubic expression, so we can't use any kind of formulas for that. Well, since we know that minus k is a root of f, we know that x plus k is a factor of f. So we can divide it in using algebraic long division. Just a reminder that even though there's no x squared in the function, I'm including it anyway because it's just in case I'm going to have x squared terms in my division. So first of all, x into x cubed goes x squared times, then x squared times these things are going to be x cubed plus kx squared. So draw a line, change the sign, as my old teacher used to say. Those x cubes cancel and we get 0. Then we have the 0 and the minus k, so we get minus kx squared. Then divide x into minus kx squared, we get minus kx. Minus kx times x plus k gets you minus kx squared minus k squared x. So I've already drawn the line and changed the signs, so those are going to cancel. And I get 0. This is where you might have a little bit of trouble. You can just multiply this out, so this is going to be x minus k squared x, and you're adding on k squared x, so that minus k squared and the plus k squared are going to cancel, so all you're going to have in the end is the 1x. Lastly then, just divide the x plus k into the x, you get 1, then 1 times x plus k gets you x plus k, draw the line, change the sign, so the x minus x are going to cancel, and then the plus k and the minus k are going to cancel, so you get 0 plus 0. But of course, all we have now is a quadratic. We don't have the roots of f yet, so that's our next step, is to find those. Normally with a quadratic expression you're going to try and factorize it, but since we don't know what k is, we can't find any factors or anything, so we're just going to have to use the good old quadratic equation. So a is 1, b is minus k, and c is 1, so k plus or minus root of minus k squared plus minus 4 times 1 all over 2 times 1 gets you this here. So whatever k is, this is how you find the other 2 roots. Part C says to find the values of k for which f has exactly 1 real root. And we can tell just from looking at this graph. Now, not all cubic functions look like this. Some of them will trail off like that, and then you won't have any of that. But let's just take this as an example. Now, this thing is always going to have 3 roots. So you have to pay careful attention to the wording of the question. It's asking for when f has exactly 1 real root. So with real being a key word there, when is 1 root of this function going to be real and the other 2 roots not going to be real? Well, what type of numbers aren't real? They're the imaginary ones, or the complex ones. So let me just move this graph to show you how it happens. If it's like this, then as you can see, there are the 3 roots. But as I move it up like this, say I leave it right there, there's 1 root here, and there's another root here. This graph touches the x-axis at exactly 1 point. Now, mathematically speaking, we still say that there are 3 roots, just that 2 of them are equal to each other. But what happens if I move this graph up a little bit more, like that? Then there's only 1 point here, and we don't say that there are 3 roots in the one place there. What we say is 1 root is real, and there are 2 other roots that are imaginary or complex. And when you're going to get an imaginary number, this here in the square root is going to have to be negative. So k squared minus 4 is less than 0, k squared is less than 4, so minus 2 is less than k, which is less than 2. And it might be worth checking just to make sure you don't have 3 imaginary roots, I suppose. So remember, your other root is minus k, and is minus k going to be imaginary when k is greater than minus 2 and less than 2? Well, no, I mean, there's no imaginary numbers in there, so k is anywhere between, so minus k in fact has exactly the same values as k there, so minus k is going to be a real root, and the values that you get from this are still going to be imaginary.